Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Aromatic stabilization and reactivity in catalytic hydrogenation. Moving on to the next step. Observe the reaction outcome. Naphthalene, P, treated with IChO over PDC catalyst, stops cleanly at 1, 2, 3, 4 tetrahydronaphthalene, Q. Only one ring is hydrogenated, the second ring remains aromatic despite IChO being present. Moving on to the next step. Interpret stops cleanly. The reaction does not continue to fully saturate both rings, i.e., does not give decalin. This means the remaining aromatic ring in Q is resistant to further hydrogenation under these conditions. And for the final step, compare reactivity. In naphthalene, P, both rings are aromatic, but each ring is less aromatic than an isolated benzene ring because the resonance energy per ring is lower than benzene. Once one ring is hydrogenated to give Q, the remaining ring becomes a true isolated benzene-like aromatic ring with full aromatic stabilization. It now has the full resonance stabilization of benzene. This makes the remaining ring in Q significantly more stable and less reactive toward hydrogenation than either ring in naphthalene P. Therefore, one aromatic ring of P, which is part of the naphthalene system and thus has reduced per-ring aromaticity, is more reactive than the aromatic ring of Q, which now enjoys full benzene-like aromaticity and is more resistant to hydrogenation. This is exactly why hydrogenation stops at Q even with IChO. Evaluate other options. A. Exothermicity. The question gives no thermodynamic data. This cannot be concluded from the observation alone. C. States one ring of P is less reactive than the ring of Q. This is the opposite of what is observed. D. Refers to relative rates of successive C is equal to C reductions within one ring, which is not what is being demonstrated here. The key observation is inter-ring reactivity difference. Therefore, the correct answer is B. Therefore, the correct answer is option B.